Hello everyone. Welcome. I'm really excited to be hosting this new first flight. So I'm just going to wait a little bit until people joins. I think we already have 11 people. That's nice. And we are on our fourth first flight, and that's amazing because we have gotten this far and we have a lot more of first flight coming. So, if you are someone who already submitted some findings into other first flights, welcome again. On this week challenge, we are going to have a really interesting project. But if you are one of those who doesn't know what first flights are, or you are new into this auditing world, welcome. First flights are our effort to break that gap between experienced auditors and newcomer ones to the space. And with these first flight projects, we provide you with a smaller code base with already known issues and vulnerabilities for you to practice and hone up your auditor skills. So you are going to experience by firsthand how to be an auditor is actually like. These projects are also easier than the other more complex ones and are intended for you to practice and improve your skills. But before we start on today's project, or I must say on this week project, we have a little announcement for you. And let me just change it and share my screen. Yep. So we are about to launch our education platform called Cypher Updraft, and some of you watching this might already have signed up. But if not, please go to updraft.cyphering.io and apply for the early access. We are going to have the better quality, or I would say the top-notch quality in industry courses on Web3 development, and soon enough, security as well. So if you want to know how to become an auditor yourself, starting from scratch, please go and apply for the early access. It's 100% free, and we are going to have a lot, and I mean a lot more of content coming up. So with that said, let's get started with this week project, shall we? This week project is called Boss Bridge. And this is a simple protocol for you to transfer tokens from a layer one, in this case, for example, Ethereum mainnet, and a layer two, which could be Arbitrum, for example, but in this case, this is intended to be to use with CK. So before, before we dive into the description of the actual project, and I'm going to actually make this a lot bigger for you to see it without problems. And before we delve into this description, let me go to the first steps, which is going to be clone the repo of the project. So let's copy this. You need to have open your terminal, of course. Go to the folder, paste it. We need to wait until this process finishes. It shouldn't take longer. It's a really small code base. Let's go into the actual project, and I'm just going to run forge install. This is going to install all the dependencies, and on the meantime, this is working. I can return and now start explaining what the project is about. So the first thing you need to know or do when you are starting your journey on these first flights is to actually understand what the project is about. And the best place to do so is, well, start reading the documentation on, in this case, the project description. The price pool, as you know, for these first flights are in terms of experience. I'm going to skip that for now. And we can start with the ends log. We have a 99 lines of code to be audited on this project, and with a complexity score of 106. If you have participated on our other first flights, you might remember that the last one was actually 3 times harder than this one. So we are going to vary between the complexity of the projects. So the Boss Bridge project presents a simple bridge mechanism to prove our ERC20 token, to move, our ERC20 token from an L1 to an L2. Again, an L1 such as Ethereum mainnet, and an L2 such as Arbitrum, or in this case, Zk sync. The L part of the bridge is still under construction, so we don't include it here. So we just have to audit the smart contracts in the scope. In a nutshell, the bridge allows users to deposit tokens which are held into the secure vault on the L1. Successful deposits trigger an event that our off-chain mechanism picks up, parses it, and mints the corresponding tokens on the L2. So basically, you deposit your tokens on this L1 solution. This is going to trigger the event, and that event is going to make the L2 to mint those new tokens on this protocol. Easy, right? And we also add some simple security measures for this project. First one is the owner or the bridge or of the bridge can pause operations in emergency situations. Because deposits are permissionless, there are a strict limit of tokens that can be deposited, and the withdrawals must be approved by the bridge operator. As I said before, this is going to be used for Ethereum mainnet and Zk sync. Again, we have some restrictions here. For example, that we are going to suppose that the scope is going to keep to L1 token.sol or any token which is similar to this one. I'm going to show you this later, because there are some different ERC20 token standards which are kind of weird. For example, USDT, which has some different things. Again, if you want to learn about this, you can just click on the link on the actual documentation, and you can start reading about weirdness on ERC20 tokens. So with that, we have a basic understanding of what the project is about. Now, what to do next? As you saw before, I just start installing the dependencies on my terminal over here. I'm going to clear it, and I could just open Visual Studio Code. If you are using other code editor, I'm sorry, but you must use Visual Studio Code because it's the one which has all the extensions and cool tools we as smart contract developers and auditors use on our daily basis. You can still audit using other tools, but we highly recommend you to use Visual Studio Code. So let me make this bigger in order for you to be able to see it without problems. And again, after you clone the repo and install the dependencies, you should go to the README file. Let me open the preview. And as you can see, we have the exact same description as we have on the web page. So you can start reading this again until you understand, especially what is the scope. So the scope for this project are these 4 smart contracts. We know the Solidity version, the contracts, and other parameters, for example, which are the actors, for example, the bridge owner, the signer, the vault, the user, etc., etc. So the first thing you need to do here is to understand, at least on the higher level, what the project is about. And then you need to start making some interesting things. For example, if we have this scope with all of these smart contracts, and I actually think it is too big even for showing to you. Let me put it like this. For example, we have this L1 token, which is a pretty standard ERC20 contract, which is important from OpenZeppelin, just 12 lines of code. Maybe not that relevant, but still is under the scope, so you need to check this out. So what to do next? Basically, we can go again to our terminal and run forge override. And again, if you haven't used any of these tools before, and I mean, you haven't even coded with Solidity or Foundry yet, please don't forget to go to the early access sign up on Cypher Updraft, because we are going to have courses to teach to do everything you need from scratch. With that said, let's continue. If I hit enter with the forge coverage, I'm going to have this nice graph on which we have all the coverage in terms of test. So it seems that we have almost an 100% coverage here. So that's it, right? Contest done. every any test are already written. Well, not that, not quite that. This is just like the first steps. So first you need to know that, for example, the L1 Bros bridge has a coverage of 83.33%. It means that it has test for 5 on 6 actual functions. So you can go to the code, go to the Elbows bridge, you can see this is the smart contract, and you can go to the test folder and start creating your own test for this thing. Also, the second step, mostly you are going to be doing is use an automated tool such as Slider. So I can just use Slider on the SRC, and this is going to run this automated static analysis tool. And we have a nice report. For example, we have here something in red, if I'm not mistaken, like, wow, this contract, the L1 boss bridge, uses arbitrary from in transfer from token, and this might be a vulnerability. However, anything came from a slider or a static analysis tool is not going to be considered by the judge, because anyone can run one of these tools, right? And just like copy and paste what the tool says, and that's it. They have a submission. We want you to actually go the extra step and actually start understanding the actual not obvious vulnerabilities. However, I show you as leader because, again, if you're starting your journey as a Web3 developer or Web3 auditor, tools like this provide you really good insights about vulnerabilities. For example, this vulnerability, potential vulnerability, give me a link I can open on my browser, and I can start reading and learning more about what this is about, which is pretty interesting and nice for those newcomers. And if you don't know how to use Slider because you don't have even how to install it, the process is actually really easy. You can just go to Slider, Citric Slider, go to the installation section, and you can install it using pip. Pip is the common package manager for Python. So you can just copy this, go to your terminal. Let me clean this up and paste it over here. And as easy as that, you can install a tool like Slider and start, scratching some vulnerabilities and some potential security risk. However, if I said that making tests is not enough because you saw most of the coverage of tests are already done, and if I said that using tools like Slider is also not good enough because they are not going to be considered on the scope, how can you actually start looking for vulnerabilities in protocols like this? Well, that lead me to my next step, which is go deep on the understanding of the actual code base. So let me share again my screen over here. Let's go back to the code. And for that, we have interesting tools. For example, if you go to the Visual Studio Code extensions, we have something called Solidity Analyzer, if I'm not mistaken. Give me a second. It's called Solidity Metrics, sorry. Yeah, Solidity Metrics. With this extension, you just have to go to the App Store or the extension store on Visual Studio Code, install it, and when you go to the actual smart contracts, you can go and make a right click, for example, on the Elbows bridge, go to the bottom into Solidity Metrics, and this is going to actually auto-generate a nice report of with the details of this smart contract. You are going to be able to see, for example, the ends log, the comment lines. You are going to have nice graphs regarding, for example, how many imports these have, how many public functions they are, how many contracts are on the scope, etc., etc. And here you're going to have something like this. In this case, this contract doesn't have it, but for example, let me open the L1 token with Solidity Metrics, and you are going to have this, the inheritance graph, so you know that the L1 token is an actually ERC20 token. And the call graph. This is which calls this contract does. So the constructor does a call into decimals and into mint. So if there is a problem with some of these functions, well, there might be also a problem with the constructor function. Once you have all these metrics, all these graphs, you kind of understand the basic structure of the smart contract. You need to start actually reading the contract itself. So for example, let me open the boss bridge. So look at this nice ASCII art. And you can start going function by function. So for example, let me put you into an example situation. We have a lot of functions here. Again, you have the documentation on which what this function is supposed to do and the params the function needs to be executed. So let me go down till the, which was the function, deposit tokens to L2. This function requires an address, which is going to be the address we are going to send the tokens to, the address of the recipient, the amount of tokens, and is an external function. One thing interesting here, for example, is that our off-chain service pick up this event and means the corresponding tokens on the L2. So if we run tools like Slider, if we make all the tests for this smart contract and we didn't found anything that we might consider is a vulnerability, these are the places we can start scratching. So this function is supposed to locks token into the vault and emits a deposit event. But this deposit event is going to pick up by an off-chain service. You know that off-chain service might get manipulated. So can we make this emit function to do something that the emit function is not supposed to do? If so, how? This is the kind of questions you need to start asking yourself in order to start finding those vulnerabilities. Because again, if we run something like forge coverage and you see that most of the functions are already covered with tests, you're not going to find any vulnerability here. But if you start asking creative questions like, okay, how can I make this function to perform different than it's supposed to perform, you are going to start picking up those vulnerabilities. However, if you don't know, like I haven't audited any smart contract before, and I don't know what is considered a vulnerability and what not is considered a vulnerability. For that, you have amazing tools like Solidit. You can go to solidit.syc. Actually, let me put this on the comments. You can register, it's 100% for free, and you can start learning about a lot of vulnerabilities on the industry. So you're going to have the latest reports. You can start reading what happened in which protocol, what uh, went wrong, and how people exploited these vulnerabilities. And with this tool, you are going to start honing up your skills. You're going to start understanding a little bit deeper how this vulnerability works. You are going to start understanding and getting more information about vulnerabilities, and with experience and with making yourself creating creative questions about how you can make functions to perform different that they are supposed to perform, you are going to start becoming a better auditor. And this is more or less how this works, or how you can start your process. Of course, we are not going to spoil the solutions or the actual audit process, because these projects are for you to practice and to hone up your skills. But let's suppose you find a vulnerability on this function, right? You said, okay, I found something that might be exploited by a bad actor. How you submit this? Well, for that, you need to go to the Codehouse page. Again, if let's say you just open the page, you just go to first slides. Don't forget again to sign up. You can do it by using MetaMask. You can go down there. This is the first flight we have available right now, the boss bridge. You can go to view, and here you can click on submit finding, and you can put here what you found. The process is quite easy, but we need to have some structure for the submission. So first, you need to put a title. The title should be as declarative and as explicit as you can. Don't say, hey, the smart contract has a vulnerability and that's it. No, explain on the title exactly where the vulnerability is and the kind of vulnerability. If you find a reentrancy attack, put reentrancy attack on the title. Then you need to select the severity. It means that a higher severity or a high risk vulnerability is one that, if exploited, could destroy the whole protocol, medium risk and low risk. And here we have the relevant GitHub links. So you know that we have the actual GitHub repo for the project, right? So don't just copy the link here and paste it on the submission. No, go to the actual smart contract. So on our SRC, for example, this one, as I said, let's suppose you found a vulnerability on the deposit tokens. Click on the line of code. Let me make this bigger actually. So click on the line of code. This is going to attach this actual function into the link. So you copy this link and then paste it over here. This way, when the judge is judging your submission, they are going to know exactly where to look. And then you have to detail this. We are using Markdown standard. So using Markdown, you use double hashtag for H2 titles, if I am not mistaken. But anyways, you need to put here a summary, be as brief and as explicit as you can. So reentrancy attack found here. Then you put the vulnerability details, what this vulnerability is about, especially because we value a lot POC, proof of code. Again, don't tell me there is a vulnerability, show me. So here you need to detail where the vulnerabilities are. So you can, for example, copy the function code, use the quotations, paste here the code, and then say, in this function, I found this vulnerability, blah, 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 and this is how you can exploit it. So you also show us how this vulnerability can be exploited. Then you can put more details, like what is the impact this vulnerability might have, the tools you used. You can, again, help yourselves using Slither or other static analysis tools. Again, they are out of the scope of this because we want you to be more creative and find the solutions by yourself, but they can be helpful to push you through finding those solutions. And the recommendations, how the protocol can solve this vulnerability. Okay, you found the vulnerability, you tell us where the vulnerability is and how it can be exploited. Then what recommendations you gave us, what recommendations you have for the protocol to solve this vulnerability and make it more secure. And that's it. This is the whole process. First, read the documentation, understand what the project is in the higher level, run the automated test and the automated analysis tools, then start writing your own tests, even on creative parts. For example, make tests for different use cases than the actual contract developer think of. Then start being more creative in terms of, if this function is supposed to do X, how can I make this function to do Y instead? And also, again, I'm going to insist, hone up your skills as an auditor, going to sododit.syc and start learning about a lot of vulnerabilities on the space. And the more you read and the more you learn and understand vulnerabilities, here, the more you are going to be able to find your own vulnerabilities. Remember at the end that the first flight projects are projects that are easier than actual audits. So they are supposed for you to practice, hone up your skills, improve, and just start submitting. With time, you are going to get better and better on this, and you might find a vulnerability or a risk in a protocol that no one could find. And you can also start earning money and work as a professional auditor yourself. But first flights are the first step for you. Let me grab some questions over here before we finish. We have here, so what is LaTeX? LaTeX is a language, is kind of similar on some syntax to Markdown, but it's more complex because LaTeX is used for math and scientific stuff. For example, if you want to create a formula, you want to create a derivative, an integral, you can write in LaTeX using like parentheses, slashes, and LaTeX is going to automatically format that into an actual function with, the shape and the image, etc., etc. Do we have any more questions over here? Where is Patrick? Patrick is really busy making some interesting content for you guys, and we are going to have a really interesting curriculum coming soon. And for that, I'm going to insist once again, go to Cypher Updraft and register yourselves for the early access. It's 100% free, and here we are going to post all those amazing curriculums Patrick is working with right now. Let me see what else we have over here on the chat. Okay, today we don't have that much questions, which is nice because it means two things: or I'm explaining this very good, or second, I'm too boring and I want someone to ask questions. Whatever the case is, I hope you have enjoyed this live so far, and I'm going to just wait maybe 1 minute if I got new questions. Otherwise, I'm just going to keep this on the screen for you to don't forget to sign up to Cypher Updraft. Here, Cryptonamus B, I hope I pronounced your nickname well, said you did great. Thank you very much. Thank you very much. And Georgie also says thank you for the explanation. Thank you, Georgie. Again, if you don't have any more questions, I think that we are ready to go. Don't forget to actually submit something, to actually put at least 1 or 2 days, maybe this weekend, to go through this project, start auditing, and honing up your skills to become a better auditor. With time, you are going to become a professional auditor, and you are going to break that gap between being a newcomer with this imposter syndrome of not knowing what to do, where to start, on how to submit, to being one of the top auditors on the industry, hopefully. So, yep, thanks, and see you on the next first flight. If you have any comments or questions, don't forget to visit our Discord, and our incredible community manager, Equius, which is actually here on the chat, is going to give you support right away. So, see you on the next first flight, and I hope you enjoy this. See you, everyone. Let me